we use those files, in particular the Eve.json and the fast.log, to look at what alerts there were. So when we look at the Eve.json, we can use the JSON query. In this current directory, look for Eve.json and display the first lot of information. And that's what the layout is. So if you're going to be programming this or doing some automation, you use the JSON file. If you are more of a script person that uses Linux Bash, you would use the fast.log file. Thank you. Based on the jQuery language, we can go through a lot more detail and use certain query languages, like select any of the messages or the alerts that are in that JSON file that have a severity of 1. So that means that's pretty dangerous, or you need to do something about it now. So 1 is bad. So that's what this is saying. Select.alert.severity equals 1. And I've just told it to grab the first few bits of it, and it will highlight that whole section related to those severities. And it'll keep showing that there. What we can also do is drill down in more detail about that, and that's what this next part is. So press Q to get out of that JSON query. And in this case here, I'm telling it, go grab all of the packets with that severity, but only show me the source IP address, the destination IP address, and what the alert was. In this case, exploit eternal blue. And now if I do that, it's just pulling out the source, destination, and what the message was. So we can now start pulling out who are our machines that are involved in this communication, so the source IP and destination. And from here, we can see that 149 is communicating to 138. 138 is responding back to 149. And now we've got another communication between 143 and 149, and so on. So we can start pulling out these IP addresses. So what we can do is using some of the Linux tools. So I do apologize if you haven't done an introduction to Linux course. What I'm doing here is I'm using some of the built-in Linux tools to sort the list, only grab the unique versions of that list and count them, and then do a reverse sort. So we can now get a count based on the highest number at the top. So we can then go and action just that part first. And so that's what this is doing here. So it's grabbed those 7,400 packets, and it's now sorted those, and I can see here I've got 1,298 packets going from 138 to 172, 138 to 149, 172 to 149, 172 to 138. So that's, and 149 going to 172. So we can see that the majority of these top 6 packets are what we need to focus on. And so it looks like we've got this double pulsar beacon response. So we need to go through and do research. Can I get you to open up your friendly neighborhood search engine, say Google, and just do a search for what is double pulsar? And this is something as a threat intelligence, if I don't know it, I would use my search engine to research it and find out what it is. And you might be able to find a CVE, Common Vulnerability and Exploit alert about that. What was it? It's a back door, yes. Well done. You get a chocolate. You should answer that before morning tea. Sugar fix. So when we look at the packet capture, as I said, what we're trying to do is come up with what is happening. So who is attacking who? And we were able to see the communication between this IP address and this other IP address. And we had a listing of at least 6 IPs that we should go maybe investigate further. Go have a look at the event logs and get a better timeline. Based on the timing, we could see that something ran the attack, and we found out what the vulnerability was based on, or not the vulnerability, but what the alert said was an internal blue double pulsar. True? And so we can go get more details about that. And this is the type of alert that we would get. So this is the timestamp of when it occurred. This is the sequencing of the alert. And then we've got the text version of what that alert is about, what priority it is, what protocol it used, and then the IP address, the port number going to this one here. So this doesn't match exactly what you saw there, but that's essentially what it's doing. So what we can do is go and look up the rule by going into the Suricata directory and having a look at the Suricata rules. So what I'm saying here is go search for this text, doesn't matter if it's uppercase or lowercase, inside this file, and then this is what that rule is that's causing that alert. Don't worry, I'm not going to teach you about that at this point. That's a little bit more advanced workshop, but that's how complex it is. And that comes with Suricata when you install it. I didn't need to create that rule at all. So with the intrusion detection system, it allows you to hopefully figure out what's happening, identify some unusual traffic, and then look at either it's TCP, UDP, IP, whatever the protocol is there. What it does need to know, though, is if you're going to do a live capture, it needs to connect to a network interface, and it needs to be able to see that traffic. Or you can basically save it to a file, and then you can replay that file using a packet capture. The difference between Wireshark and TCP versus Suricata is Wireshark captures the packets, but it relies on you to identify what is good, what is bad, and finding the traffic. Whereas the intrusion detection system, it has those rules that it uses to identify the bad traffic. And it's able to read it very quickly. So those 50,000 packets didn't take long to have a look for those 8,000 or 7,500 bad packets. So it helps speed up that triage process of what you can determine as being malicious. With rules, the rules basically you can update for free using some common locations. We're not going to do that at the moment because we're working offline, but there are some details for doing that. Our second lab is you looking at Drydex. Can I get you to open up your friendly neighborhood search engine, Google or Bing or whatever, and do a search on what Drydex is? And this is what you should be doing when you're wanting to learn more about security. Use the resources that are available and find out, oh, what does it mean? It's a type of malware. And it targets banking. So it tries to steal banking credentials. So it basically gets onto a system and looks through all of your clear text files and your browser history looking for banking details. Have you had a chocolate today? So yeah, it's a banking malware. The reason why I'm pointing this out is this was one of the more common Trojans that were hitting the Pacific region. Same process as what we did in the first lab. We did sudo suricata replay this packet capture file, and you can see here that the delivery mechanism was via a protected Word document. So it wasn't necessarily an executable that ran, it was a Word document that did the infection. We're telling it where to store the logs, and then we're going to not do a checksum. Once we run this, we're going to then use EveBox, which is the graphical user interface, to the logs. So it basically reads those logs and displays it in a web page in a nice format. Because most of you, I understand, do not use the command line very much. Is that correct? So that's why we're going to do that. But what it's going to do is read the JSON file, and it's going to then start alerting based on the signatures and group those together. What this is going to be doing is saying, look for anything that is using encrypted traffic, TLS, from the external network coming to the home network, and then match on these sort of special characters and strings and so on. It also is using a blacklist using a jar3 file. So I'll explain this when we do the lab, but a jar3 file is it looks at the TLS handshake, has a source IP address, the type of encryption it supports, and the destination ports and so on. And based on that, it can create a fingerprint of that TLS connection. And so that's what this is doing here. It's using the fingerprint to determine whether it's malicious. And that's what this is talking about here. TLS, SSL client and server fingerprinting. It takes the encrypted communication, looks at the special information related to that communication, and then it's able to determine that it's a malicious content. But it uses jar3 for the client and jar3s for the server. It was developed from, anyone heard of the company called Salesforce? So one of their technicians came up with this concept. So we can see here that we've got this jar3 fingerprint for a communication based on this IP address and port number, and we've got this other jar3 communication. And so it will be able to identify it, and this is what you see in the handshake process. The TLS, it's going to have things like the cipher suites, how many suites they support, and the actual suites they're going to use. So it has the SSL version, what the cipher is, any extensions that it uses, converts it to a string, so adds them all together. Then it uses the MD5 calculation for a hash. And that is what we saw on this screen here. Something that looks like that. So let's actually go through the process of running this and using Eve to do that. So we're now looking at Lab 2. No idea why it's doing that. And I'm going to change into my Lab 2 directory. Inside this directory, I've got my packet capture file, and I've also downloaded the signatures for the jar3 fingerprint of the SSL connection and the jar3s fingerprint of the SSL connection. I'm going to run the suricata replay of the packet capture. And that's going to go and create those 5 files in the logs directory. So we get the eve.json file, the fast.log, and the suricata.log. So in this case, it's not a very big packet capture. We've only got just under 3,700 packets. And if we go have a look at the logs directory, we can see that we've got those files there, the stats.log, suricata.log, eve.json. So what we're going to do is we're going to use evebox to open up the JSON file. And so what that's going to do is read the eve.json file, and then it's going to set up a HTTP server to display that in a graphical way. And so that's what this IP address is, my IP address of this local machine for Suricata. I now press enter, and it's going to sit there in the background listening for connections. On my analysis machine, I click on Firefox browser. Can't remember if I saved it. No, I didn't. What was the IP address that I used? And so we just open up Firefox, and you can either type in Suricata port 5636, or if you paid attention to the IP address here, we can see that it's 30.0. And if you are typing it manually, just be aware, see how it added extra characters for me? I need to make sure I get rid of those extra characters. And for whatever reason, Google in its wisdom said, oh, that's an address that we want to search for. When it does all these repeating characters, that usually means that there's high latency. So I'm just going to delete that. I'm going to see if I can get away with doing it this way. And it missed one character. So let's see if that works better. So it's saying it started, but for whatever reason, I'm not able to communicate with it. So let's go to a new terminal window, and I want to check why. If you hear that noise, make sure you renew your lab. 192.168.30. Just checking connectivity, which I do have connectivity. I don't know what I did different. I just retyped it a couple of times and it worked. So it must be the latency that's having some problems. So what you're going to get is a page that looks like this. How come there's no events? This is one of the first things that people find when you start off being an incident response analyst and you start working with this type of software like SEAMS. And what it is that your date and time range up the top here. See how it's got the last 24 hours? This is a packet capture that we took when? So you need to make sure that you check what the packet capture date and time was and you change it accordingly. So we're just going to say, show us everything. So some people get to this point and go, it's broken, it's not working. So they go back to the start and replay and delete files, and it's really, you need to think about the display filter that's there. And so now what we've got is this setup here. Is this a little bit easier to understand? So what do you think the red color means? It means it's bad. Red, doesn't it? Yeah. And we've got blue is meaning that something's been detected, but it's a color that's alerting you as well. True? The number on the left-hand side, 941. What do you think the 9 means? Nine packets have been detected with that same signature. So it's automatically grouping it for you. Whereas in the command line, we had to do that grouping, didn't we? Yep. So if there was thousands of alerts and they were all similar, it would be grouped together like that, okay? So what we can do, we can drill down on that particular alert, and based on that, we now get a lot of details. It tells us the timestamp, what protocol, the source and destination IP, the signature that was used, the severity, and also the actual fingerprint of the TLS connection. I'm just going to move this across because I want to try and scroll a little bit better. Using my fingers don't seem to work as well. So we've got a question in the lab. What version of TLS is it actually using for this? 1.2. So we go over here and we click on the TLS and click on check, and in theory it should go green. Correct? What was the source IP address? Up here it shows me what the source IP is. So what do you think the source IP is? .205. I click on check, and this is the sort of thing that you would be taking note in your ticketing system. This is the source IP, this is the port number that it used, and the port number is 443 HTTPS. I'm not going to worry about the fingerprint, but you can see here what the fingerprint is. That's a long way of typing it in. But feel free to type it in if you want. And over here, it's got information about the actual certificate of this malware. And the common name is under CN equals this one here. So that's a quick introduction to Suricata. So we've been able to use Suricata to replay a packet capture, then use the Linux command line tools to investigate the alerts. And then to make it a little bit easier for you, we've then used EveBox to have a look at those alerts in a GUI, a graphical user interface. Any questions? So with the intrusion detection system, we're able to look at unencrypted traffic, and then we looked at encrypted traffic, and we're still able to create alerts using that system of the fingerprint concept. So it's able to look at doesn't need to look at a particular port for a protocol. You can look at the header information and understand that there are traffic on other ports. You can also look at the packets themselves and then using the payload determine things like the TLS and match it to a signature that is on jar 3 or jar 3S. How's everyone going with that? So that lab is available for you to continue this later on if you would like. We're going to move forward onto the next part of the program, which we'll have a look here. I can find my mouse. This is the worst thing about the Mac. It doesn't show you where your mouse is. So we're going to look at log management. So this is once you've been alerted to a malicious traffic of some sort, or your intrusion detection system has found something, this is where you go to the endpoint device and you start looking at the logs. True? Yeah? So this is the next part of that investigation process, or the incident response, or your network analysis. So you start looking at your logs. So with your lab, if you want to continue this later, you can save it at this point. My suggestion is that you just cancel the lab and you come back and do it again from scratch, because it'll give you the same couple of hours again, because we're going to start opening up another lab soon. So make sure you're comfortable with logging into the academy, exit the lab that you're doing now, and you can always come back and do more.
Gimana, Pak? Thank you. I have a question about the what is the
Suricata.
Suricata, yeah, Suricata. I want to know the real case about use the Suricata for the analyze the malware. It is we need the computer to get the malware. After that, we analyze, or we just analyze in the traffic for the client who is the victim of the malware. Thank you.
So there's two ways to use Suricata. One is real time, And so what you do, you would install it on your network, and then you would send the traffic to Suricata, and it will start inspecting that traffic real time. And then what it will do, it will start creating alerts and saving that into those files, those 4 files. And then you can use EveBox to look at that. So you need to refresh on a regular basis so you get the latest alerts. So if it's your network, you will get an alert, and that means that you know that there's malware on your system. So you get the source IP or the destination IP, and if it's one of your machines, you would then try and isolate them from the network, because that means the attack has already started. If you see the alert in real time, it's already started. If it's a customer, like I work for a managed service provider, as part of our managed service, every so often we would run packet captures on the network just to see for the baseline and then compare it with the baseline. So we would replay it through the Suricata. And if there was any unusual traffic, we would then ring them up and say, we've detected unusual traffic on your network. Would you like us to do anything about that? Sometimes they had no in-house IT, so they would say, yes, come immediately, and we'd send a consultant or someone from the team to go down and help them. If it was part of their monthly contract where they had 24/7 support, we'd automatically send someone there. Okay, that would be the use case, whether you want it to be real-time alerting or whether you don't do post-investigation. But in reality, it can be used for a learning tool for you at the moment. That would be the use case at the moment, is that the websites that I've mentioned in the lab guide, the malware analysis, will allow you to basically download samples that they've already done on your behalf in a isolated location. So that means there will be malware in the files, so you need to make sure you don't do it on a production network, you do it in an isolated machine. Okay. I can talk about more if you like after. Good question. Get some socks.
Okay. Thank you, Warren. Right now, we will move to another subject, but I think still related with the last lab, because we're talking about how we collect logs from the system. Either that's a traffic log on the PCAP or log from your equipment, either from the network equipment or from the server or the resources. We talk about the log management. So basically what we're talking about here is we're talking about logs and how it can be managed and how it can be centralized. We're talking about technology called syslogs and the terms that you should know and how to use it to manage all the logs using tools. So basically, we talk about logs. It comes from your infrastructure, like a network infrastructure. You have a firewall, you have switches, you have a DNS router, load balancer, even your server like a Linux or Windows. It all also has logs. They create logs, like also in your application when you start the web server, the DNS server, your database server, everything that create logs. Logs allows you to see the what happened to your system. Like for example, someone get access to the system, it written on the logs. If there's something happen, like something that crashed, the program crashed, it's also in the logs. So basically, it's a thing that allows you to know what happened to your system. So basically, you need to know all of them, since you have lots of resources on it. So basically, if you have a way to manage those logs, you can find out what happened to your system. So So you don't look at the logs one at a time, because it will make you like you don't do that, because one service is like maybe you have one server. It consists lots of logs. You don't open like when using Linux, you type tail -f/var log messages and you just wait for the log. You don't do that because what you need to is to send this log, copy this log from every resources of what you have, like from router, from the server, to one centralized place, one centralized server. So what we are going to do is to orchestrating those logs. And everyone also think about this log will consume a lot of storage, and of course, because they will collect all the information from your each devices, each resources, and you need to find a way to manage them. And not only you just keep the log, but you need a way to find out what logs are important, to correlate between each log that are connected, to find out the insight. Something happened when there's a network log from your router and from your server. You try to find the correlation, or something is happening on the system. You cannot do that when you see the log to each system manually. So you will need that because you want to troubleshoot or debug something. You also need for security, for compliance and performance monitoring. So it will answer your question. The most difficult question that every network admin, when the customer tell you why the network is slow. It's a very difficult question because you have lots of things going on, from the upstream internet to your gateway router, to your firewall, to your switches, to your access point, to the devices. It's very difficult. It's rather just answer the question why the network is down. It's easier. You say a network is down. Yes, I know, because the upstream gateway is down. I know. Why network is down? Because main router just reboot. Okay, I know network is down. After the reboot is complete, I know network is going back again. But why network is slow? You need a lot of things to do. You need a lot of information. So you need those logs to help you to understand what happened. It is the most difficult question, as I was from the network administrator. People just ask me, I'd rather just answer the question. Then, okay, network is down. It's easier to answer. Because network is slow, I need to investigate. I need to check up logs. I need to ask questions. Where are you accessing the internet? What kind of devices are you using? What SSID of the access point that you are trying to connect to? What's the DNS services that you're using? What's the DHCP that you're using? Lots of questions. And logs, centralized log, will help you solve most of the question. So we talk about there are 5 parameters for a complete log management process. The first one is a collection. There are like 2 types of the collection of the log. So it's like agent-based. So most of it are in the usually for the server. If the server doesn't have a log collecting facility, log collecting system, you need to have an agent to help them push the log from the server to your centralized log. And you're talking about agentless. Usually when you have most of the Unix, almost all of the Unix Linux server usually have the system called syslog. So basically it allows you to collect the logs and help you to send the log somewhere else to the centralized server. Yeah, also the second one is the storage, in how you process of storing the file, compressing, encrypting, and archiving. So the log file is like a text file. it's not like a binary file or something. It usually text file. We get a lots of it. But fortunately, logs file are very easy to squeeze, or very easy to compress. If you have a maybe like gigabyte of files, suddenly when you go tar gz of that file to compress it, usually you will get like maybe like 50 megabytes of file. Suddenly it goes very big to very, very small. Why? Because it's a text file, so easy to compress. We also talking about encrypting because for some compliance requirement, you need to make sure that nobody can get access to the file if there is the personal information. You have a compliance, like for example the GDPR or another standard. And to archive the logs, say archiving is like you move the files from the log that you process to get the insight to something that you just store it and you just use it for backup or archival purposes. You just save the file, you just don't lose it, but you don't manage it very much, so you can basically even change the, move the storage to other type of storage that is not on the server. For example, if you have a tape backup system or the other backup technology that can be used, maybe you can right now people just export it to the cloud. They have like archival storage. It means that you can save it to the cloud. It pays very little, but when you download it, you need to pay it more. Also, for after you have the logs, you need to have search facilities. You just don't get to see each file individually to search. You need to something to help you to search the logs. The fourth is the correlation. Correlation is a thing that it's more advanced than the search. It allows you to correlate more than one logs, like 2 or 3 logs, to find out, okay, this is this event that's duplicating on it happened on one or 2 or 3 devices, and so you can know, oh, there's something happening here. So it will help you to do that, and after that you will want to have the output. For example, you have a dashboard, you have a report or logs, or maybe you can convert it into an alert. That's the result of it. You can see that on the reference here in the lower this below. Okay. Afterwards, we have this how we can imagine the centralized logging. You have a server, you have a router, switch, application. You need to ship the log, send it to the centralized logging server, and after that, you do the post-processing. It means the search, correlation, and output when you see the result of your logs. So your log means something. Your log means you have an insight. If you don't do this in the post-processing, it means that you are wasting the hard drive space. You build a server with a lot of hard drive space, and you find that your space is full, but you didn't get the insight. That's a wasteful. So what you need, you have to post-processing thing here to make sure that the log give you the insight of your event, what happened in your network. So we talk about how do we will manage the centralized log. All the manage, we need to send it to the central log server. It helps you to normalize the differing log format because because there are many type of logs created from the router, from the server. Their structure is a bit different. So to make sure that it can be correlated, you need to normalize the format of the log file. So sometimes the log file, you have first column is the time, Second column is a date. Third column is a like source IP address. Fifth column is the event. But in other software, in other devices, it's a bit different. So you make sure that you have a way to normalize so they can be easily searched by the system. So it allows you to see to all of your logs in one single view, rather than you see it individually on each of your devices, especially when you have lots of devices. It is an example of the logs. So for example, in the top one is the SD1 controller from the Cisco. You have some software called vManage. vManage, as you can see here, it's you have one column is the logging information. The second one is a date and the time, and the third, and this one is the name of the router. This is the name of the process, and this is the log notification. So basically, it's happen a little bit different compared to the logs from the server from the Ubuntu. Ubuntu, you see, it says the first one is a date, the second one is the name of the server, the third one is the name of the process SSHD, and the last one is the information. That is, okay, it says that accept password for APNIC from the IP address, port number. You see that there's a lot of quite different. So let's explain what happened on the logs here. This is a date, December 18. The time is 9 p.m. 21:12:36. This green one is the name of the server. The orange one is the name of the process, SSH process. And you can see that in this one, the systemd is like the name of the process. So it tells you that someone just logged into the server using username APNIC. From the client IP address is 192.168.100.9. Port number. This is the process of SSH2. And also you see this is PAM Unix. PAM is actually a pluggable authentication that this user can log in the server using SSH, and it's tell you that systemd is the system of the Ubuntu, tells that this user just entered the login in with the root privilege. So this is what happened. It's only very simple type of log. You can have lots of different type of log, depend on your application, depend on your network devices. It can be different, but still a little bit the same. Usually they were categorized as okay, this more like the authentication log. It also have the like system log, or it can be a log for the a lot of thing could happen. So this is how you can configure centralized logging, is by telling the system to send the log to the server. This is a configuration from Cisco router. Just tell them to send the log to this IP address. In Ubuntu, you tell them that for the rsyslog.d, you need to send them all of the log *** to the server at 192.168.8.20, and the port number is 514. For Juniper router, you just set the system syslog host to send any with the info type, and for MikroTik, you can just do to configure the remote logging. Okay, so it's like for the Cisco port, syslog ports. So basically, it has a 514 port in the protocol, UDP or TCP, but um, it can already also on the type of protocol TCP for the reliable syslog, and also there are port 601. But I guess most of the time people just use 514 in UDP or TCP. And someone has also tried to put a TLS on syslogs, so basically it can run encrypted log sending. So, but basically, when you send syslog to other servers, basically run unencrypted. So this is a way for you to encrypt the log shipment to the syslog server. Okay, there are type of logging levels. Actually, you can choose which event to log. So basically, maybe you will consider to log the level 0, 1, 2, or at least you can log the 3 and 4, actually, just to make sure that the important event are sent and you know that something happened that's important. For the level 5, 6, and 7, it's actually something that's okay, it's normal, it's operational messages, or 7 or debug. When you send all of the level to level 7, you actually basically send all of your system telemetry to the server. It can, you will see lots of things happen, like the heartbeat of the system. Most of the time, you will need just like, say, like a number 4, like a warning, error, critical alert, and emergency. That allows you to, okay, the system is something happened, maybe like there's a problem with the hardware, there's a problem with someone authenticated with maybe unauthorized. Maybe there's something that you want to see. But most of the time, you just collect like the 0, 1, 2, 3 or 0, 1, 2, 3, 4. Their type of logging facilities. It's usually used on the Unix or the Linux machine. It allows you to choose which facilities that you want to log. For example, when you choose a kernel messages numeric code 0, it will tell you about the hardware failures, system crashes, driver issues. For number 1, it can send you the custom application logs. Number 2, mail system. Number 3, system daemon like cron failure, Docker issue, SSHD stops. Number 4, the security authentication, failed sudo attempt, file violation, TACX plus logs. There are lots of type of the logging facilities can be used. So when we want to build the centralized server, what software can be used? There are lots of server that can be used. The famous one is syslog, ng, and rsyslog, but the modern one are Graylog, Logstash, Log File Navigator, and Grafana Loki. It's the software that you can use to build the centralized syslog server. The most famous one are syslog ng, because it can support a lot of feature on it. You can use real-time log normalization. You can forward to files, forward to the database, for example, the Postgre. Or you can forward to the MongoDB, Elasticsearch, and Kafka. It can integrate with Hadoop for the big data. It can also it has flexible log pipelines. You can, if you want to do structured data transformation, you can see on the documentation on it. For this, the legacy logs. Legacy logs are unstructured, and they have followed some older standards. So, for example, most of the log has happened like this, but the problem are these logs are lacking the consistent formats. It's like make them hard to search, analyze, correlate in a tool like Elasticsearch. So software like Elasticsearch can do correlation, but it only happens when you normalize all of the log file that you receive and you put on the Elasticsearch. So what is happening to when you use logging to the Elasticsearch in traditional way? There's something software called the Beats. Beats is a software that allows you to collect the log from the server, and after that they will send you to Kafka and to the Logstash and the Elasticsearch. But right now the syslog ng client can send to the syslog ng server. It can also just export directly to the Elasticsearch for the processing of the data. This what happened is if we want to send and to export the logs to the Elasticsearch, it can be with the name of the server, the index name, username and password, and you just send the logs. The second one are our syslog. Our syslog is more like also like syslog ng, but it has some of the feature. But it can also the log of the R syslog can be shipped to the SIAM software. SIAM software, for example, the WASA, the Elastic SIAM, the Security Onion. It can process the log from the R syslog and become the log feeding. You can feed the SIAM to see, to correlate the security event. For a use case, you can deploy it as a relay chain. For example, you have a lot of edge devices, and all of them just send it to the rsyslog server, and afterwards you can send it to the which SIAM that you want that you can run. There are types for this. For example, we have for log analysis, we can send from rsyslog to Elastic SIAM. It allows you for the detailed log visualization and trend analysis. For example, if you see that your server is like they have a trend for some when you spot a trend, like maybe this will have a hardware failure or the software that has a problem with it. The second one, for the security compliance, you just use the WASA with the OSEC integration. It can be used for the real-time threat detection and the compliance monitoring. So that's what software can do. So for network monitoring, you can use the Security Onion, because Security Onion allows you for comprehensive network traffic analysis and security monitoring. So basically more like Security Onion, you can put it on the network and try to do the network traffic analysis, and you can find the insight of it. The other one is also a software called Graylog, because it comprises of the Elasticsearch for storage, MongoDB for config, and Graylog server for processing. So it will store logs, data, and provide search capabilities to the Graylog servers by Elasticsearch, and MongoDB for storing meta information and configuration data. That's this is the feature of the Graylog. You can check it on the website of the Graylog. And also one of the quite famous one is the ELK stack, or the it means E means Elasticsearch, L means the Logstash, K means Kibana. It's something that allows you to ship the log and do the search on it and visualize the log using Kibana. The Bits is a software that allows you to ship the log from the 100,000 of machine to send it to the Logstash and the Elasticsearch. This the architecture. You can see the website of the something like ELK stack. I mean Elasticsearch. Why do you use ELK? You see LENK. I don't know. Data collection, data aggregation and processing, index storage, and analysis and visualization. And Grafana Loki is like a software from Prometheus. Prometheus is actually usually used for the data system telemetry when you collect the data from the system. But Grafana Loki is like you collect the data, collect the logs from data and process, and the Grafana is used as a dashboard. Lots of things we can do on that. We have 3 components of it. The first one is the agent called Promptail. The Loki is the main server for storing log and processing query. In Grafana are using for query displaying log, more like in Kibana. It's more like a more similar one from the ELK stack and Grafana Loki, but like it's both of them are quite modern one, but it has a similar purpose to collect logs. So this is a reference. You can see it on your check it on your laptop. Try to thinking about which log service that you would like to use. Usually people seeing the log, I want to have a beautiful UI, beautiful dashboard to see my log. But actually, what you need is data that can fit to your log, and try to correlate the data so you can create a beautiful dashboard to see something happen on the network. So I guess this is the, maybe you have any question about maybe what you're thinking about the logs. It is how we can do log management. Maybe any question, ada pertanyaan, silakan. So I guess for the logs.
Are we doing the lab?
Okay, I guess we can do the lab.
So you may have to re-log into the Academy because it's been over 30 minutes. So make sure you press refresh on the APNIC Academy page, re-log in, and then you should be able to go down to session 2 of today and click on the log Academy. Maybe the internet's saying it's lunchtime. If the food's ready, we can go for the break now, but we need to come back early so that way we can start doing the session and get that out of the way. Hopefully you've got a photo of the password. So the password's here. Manning5 Jimmy_pints. It may not work because you're not logged in. And the other thing is we have changed the URL up the top from non-core labs. So you'll need to... So we've just taken the authentication off the screen. Once we're logged in, we'll bring it back. Then just bring it back on the screen. So up the top, see how your URL has no lab ID? So you need to copy the lab. Just, you can open it up again if you want. So the main thing is, for whatever reason, the Academy website drops off the lab ID. You need to make sure in the URL up the top here you have a lab ID. Otherwise it will say it can't find it. So what you're going to do is launch the lab, and this is going to create a whole heap of virtual machines in the background with some routers, and then you're going to set up the environment to capture some of the logs. Has everyone been able to log into the Academy again? And are you in the process of starting your lab? So we're just going to do part one, which is to set up the syslog ng. We're not going to worry about the other parts at this point. The process is going to be very similar, but the different software allows you to look at how the log management is done. I think the more common software these days, if you have the licensing for it, is Greylog, but most people at a minimum would be running syslog ng. So what we have is 3 routers, a switch and a host machine. That's going to be your central location for storing your logs. We're going to configure our routers to share their logs with the central location, and we're going to install syslog ng to do that. Click on next. So we've already installed all the software. So notice the command up there in the first 2 dot points. It says update software, install required software, and we've put the word done. You'll also see that there's a green tick next to the sudo apt update down the bottom. So just like our first lab, we have already saved you time by not installing the software, getting you to install it, but we still leave the instructions for you to do that. So I want you to SSH to the 30.10 and you will see that you've changed from host 1 to group 30. So scroll down. So now that we've ready to start, we're going to check what version of syslog-ng is installed. So we run the syslog-ng, which is the software, and then -- version. We can see there that it's version 3.25.1 that is running, and then some of the settings that are enabled down the bottom. We also see the module directory and the different paths that it's going to be using for its configurations and accessing the logs. We can modify the way that syslog runs by updating the configuration file, and we can just have a quick look at what's inside that file. The password's training, all lowercase, and we can see there that it has things like sources, destinations, and so on. If I get you to go Q on that, and if you run the next command, it basically will pull out what's in. So the sudo grep in, just run that. So what I'm saying is go search for anything in that configuration file with the word internal, and then show me the 2 lines after it. So press enter, and this is going to show us the different categories of what it's trying to do. And if you have a look, it's cut some of the location off. So see how it's got NGONF, so arrow up, and then do .c. And it's missing the syslog-ng/syslog, so there's another directory. No. So when you've got high latency and this many people doing the lab, it's sometimes when you do that pasting of the text, it will drop some off. So you need a -ng. So we can see here, by default, it's not listening for any traffic to come to it. So we need to modify that internal to add the IP addresses of the IP addresses we want to listen for logs to be given to us. So that's what that sudo sed command is going to do if it doesn't stuff up, and we press enter. And then we double check by replaying that, go up twice with your command and press enter. And we should now see that it's listening for UDP traffic. Normally I would get you to do an edit of the text file, but this is just a search and replace and adding information in. So hopefully it makes it a little bit easier. If we go and have a look at our conf.d directory, inside there will be no files, but if we want to do some sort of custom configuration to be allowing other devices to share their files with us, and we want to influence the way those logs are going to be stored, we can create a text file here called, say, router config, switch config, or it could be vendor. It's basically something that's going to be unique to that configuration. So I'll get you to paste that in, and again you can use a text editor to do it. Just to break it down, what you have here is I've told it to create a file called routerconf, and anything after this cat command, until you see the end EOL, end of line, which we've got down here, just store it in this file. So the first first part is saying we're looking for filter of routers with a facility of local 0. We want you to log the sources, information based on the router, and the destination of the router. And then what I'm telling it to do is where we're going to store that file. So this is how I'm going to create the file. It's going in the var log directory under the name of APNIC. But as part of this information that I gather about the logs, I get information about the host, and the timestamp is going to be the year, the month, and then I'm actually creating this folder. Then inside that folder, I'm saving a file with the .log extension with the name of the system, the year, the month, and the day. And then I'm changing the permissions of that, and then I'm specifying how we're going to save that based on the template that syslog-ng uses. There is documentation for that, but most people look at the template and they just copy and paste and reuse that template. There are identifications of some of these variables that you can use to pull out of those logs that come to you. So we need to make sure, just do we did do a cat, so that's good. There was no missed information there, hopefully. File, I'm just checking. See here, see how there's missing. Just double check, scroll over. Oh yeah, no, that's fine. Oh yeah, it's double down here. So yes. So I'm just making sure that there isn't a missing character here. It's down here. So only thing that we need to do now is this directory var log apnic doesn't exist, so we're going to create that directory. Press enter. And then we're going to have to restart our logging server to make sure it applies those configuration changes and it picks up that new router grouping. So we're now going to restart it, and we see that it's active, and then we're going to see if it's listening for logs. So press Q, and SS is just show sockets. It's a replacement to the netstat command. And so what we're looking for is that we want our log server to be listening for any connections on port 514, and that's what we're looking for there. That's it for installing the software on your server and getting ready to start accepting your log files. Now you need to go to your network devices or your endpoint devices like your laptops or servers and say any of your logs, go share it with this centralized server over here. Can I get you to do that? So click on router 1. How many people use Cisco routers? Cisco configs? A couple. That's going to be interesting. I'll just read out the code. So press enter in the window. Type in enable. And you can't do the break command because it's in a web, which is a pain, so we've got to sit there. We've typed in, did a typo, and so what's happening with the typo is that the router tries to do a lookup of that command, thinking it's a domain name, and it's going to wait for a timeout. And because we're configuring it in a HTML page, we can't do the control break to break out of that to stop it. Okay, you're back. And then just paste the first one. And what this is doing is setting up our interfaces to start the connections. So simple, connect to the remote syslog server, connect to router 2, connect to router 3. And then this is the actual commands for setting up logging to a centralized server. Logging 192.168.30.10, the IP address of the server that's running syslog-ng. Then we're saying what we're sending. and then what other information that we want to. Yep. So run that. Oh, you've already run it? Okay. And then the next thing is to make sure you have connectivity to that server. I've seen a lot of people configure the centralized logging, but they've got no connectivity to the server that's running the centralized logging because of VLANs and so on. So the ping command confirms that we've got access, physical access, and then we can see what we've configured by showing the logging. And so what we can see here, logging is enabled. There's been 0 messages dropped, 6 messages rate limited. Oh, did you press the space? Rate limited. There's been 2 flushes, but this is what we want to see. Console logging, level debugging, 222 messages logged. So we can see that there are messages being logged at this level. So that's good. We've got some information happening. So flip back to the syslog ng server. And in here, we can now look at our log. So change into the log directory where we're storing the logs. Press enter. And then I'm using the tree command to give you a visual representation of what's under this directory. So we can see here we've got the IP address, we've got the year, we've got the date, and then we've got the name of the log file. Now, because our router may not share its host name, it's using its IP address as that host name. The year is 2025, the month is November, which is 11, and it's storing that log file in there. Now, what we can do is start looking at that log file. So this is all we've got in here, 2025, logging to host, port 51, started. So I'm saying look for that. That's it. It's now running at this point. All you now need to do is any of your other networking devices, you can go and configure that configuration. That's what the lab's doing here. It's allowing you to do a Juniper configuration and so on. I think that's actually a good opportunity to break for lunch. You can save your lab, go have lunch, and if you want to come back before 1:30 and finish or do this lab, you can do that. Any questions? So the IP address 192.168.30.10, can I get you at this system here? Afan, are you able to type in IP over in the console window? Type in IP space -BR for brief. It's not a command there. So over here, -BR for brief, not, so dash space ADD for address, show, enter. And so we can see here, this is the syslog ng server's IP address. So you're telling the router, go communicate with the syslog ng server and send your logs to there. Of that server. Yeah, so whatever your IP address you're using for your syslog server is what you would then tell the router to connect to. So if you use 10.10.0.1, you would use that. Yeah. Any questions? Who's hungry? So you can leave your lab running because up here is how much time you've got left. And so even if you go away for an hour, it will still be okay if you want to do some work on it after you've eaten.
Layak pergunta.
This one.
Yeah.
No, that
Like-
doesn't work. It's not synced.
No battery.
And that, I think it's got a battery, it's just that it's not synced too.
Layak pergunta sona então kita bele break bal musu. Iminia lab maxi seni maxi lab sidau consegue halo hotu bele safe bele almoço lalais mai halo tama mai larang halo bele halo hotu. Yap. Oke, então magnerit bom almoço.
Dia colega Sira, itania horas almoço nene to 1:30. Tambah horas ho pos matéria barak makita Sira be to ne ba então horas almoço ita se vele acelera ituan. Depois husba colega Sira be mak foi preenche lista presença nian. Tambah amiting serba imprime ona certificado Sira ne. Al favor, se maksirau kakerek naran, se bele kakerek agora kerangona, tambah tempo mos, nune lokrai kita bele fahes sedus, itene certificado sira. Dia obrigada, bom almoço, ita hasor malu fali 1:30. Obrigada.